Hi, my name is Bailey Stump, and I'm an applications engineer for Citizen-Cincom here in our Fountain Valley, California office. And today I want to talk about tool load monitoring on a BNX-51MSY with a Mitsubishi controller. Tool load monitoring provides a way to forecast tool change intervals and help mitigate the chances of tool failure producing bad parts, damaging other tools, or even the machine. The load monitoring function samples and keeps track of servo torque on user-defined axes during the cutting process. Once a cutting process has been proven out and stabilized, load monitoring can be initialized by establishing a baseline load reading. This process is called sampling. Once we establish our baseline, then we can move into monitoring mode for production. As the cutting tool wears, the torque load increases. Load monitoring function will then compare real-time load data with the baseline values. As the load increases by percentage over baseline, the load monitoring function can issue 3 levels of control over the production process. At this time, tool load monitoring is an option that needs to be activated at MC structure, and you will need a password. Getting started with load monitoring requires a few considerations. First, tool load monitoring should be utilized after your cutting process has been validated and stabilized. This function is not really suited for when you're dialing in a part for the first time. Any changes in cutting conditions can affect load monitoring. Feed rate changes, depth of cut, even changing the coolant type. I think it's a good idea to have a dedicated warm-up program that lives in the machine. This program should turn on all spindles and move all axes. This warm-up program should run for 20 to 30 minutes before executing load sampling. The final major consideration is that you should start sampling with all new tooling. Most of the screens you'll be working in will be found in the offset page. The first screen I want to talk about is TM set. These are global settings for load monitoring function. Here we can control how overloads are handled. These are the 3 major levels of production control I mentioned in my introduction. All of these are adjustable up to a maximum of 175% over baseline. The hierarchy must be followed as far as setting these values. Alarm stop level should be set higher than cycle stop level, and cycle stop level should be set higher than warning level. The machine will issue an alarm if these values are not set correctly. If the warning level is reached during production, the machine will issue a caution message. Production may continue, but at this point a tool change is likely needed. The cycle stop level will issue an alarm but complete the current cycle. The alarm stop level will stop the machine immediately in the cut, such as in the event of a catastrophic tool failure. Next, I want to talk about the TM sample screen. In this screen, we're going to choose which tools we are going to monitor and additionally which specific axis to monitor. It is important to be sure to clear out old values. Once load readings are captured, they stay in the control. These are not program-specific values. While you can note these values on a specific program and re-input them next time the program is run, it is very much recommended that you redo load sampling every time a job launches. You must have the tool and axis set to valid in order to capture data during sampling. If the tool or axis is not set to valid, nothing will be stored. You can manually input data by selecting an axis, making it valid, and then using the absolute incremental button, you can actually input a value. To start sampling, we're going to select base measure. With this mode active, we will then run 3 to 5 parts in automatic mode to establish our baseline load readings. Once we have completed our baseline run, we can then deselect base measure. Additionally, we do not have to stop the machine. Now I'd like to cover the programming side of things. There are 2 M codes regarding load monitoring, M220 and M221. M220 is load monitoring off and M221 is load monitoring on. If load monitoring is active on a tool, load monitoring will still work without using the M221, but it's strongly recommended to use M221 in all of the applicable cutting processes. While the machine is in automatic operation, we can monitor the load on currently active tools. Here we can watch the graphical display as the tools are in the cut and see readings reflected against baseline. So the machine is stopped in the cut. While the alarm stop is active, you can jog or handle the bad tool out of the cut, but before you can do anything else, the peak value needs to be cleared on the overloaded tool and axis. The operator will go into the offset page and select Alarm Search. This will jump to the tool that has a currently overloaded axis. Here you can clear out the peak value. If this were a real situation, the operator would back the bad tool out from the material, clear the peak value on the overloaded axis, and exchange the bad tool for a new one. At this point, you would be able to go back into production.